Okay, folks, let's get going. So, Steve, you want to share your amazing results? I saw you were at 16. Are you up even further than that?
No, I was at 14 last week. I was at 14, but I'm dropping back. I haven't really managed to. I think I improved slightly, but it's hard to tell just because of the two digits
thing
in the thing.
The thing I was wondering about, because I was trying to implement, I didn't have much time, so I didn't do it. But if you could share how you do the fine tuning and then export the embeddings after doing that. I mean, do you split the data? Do you just do it on all of the data? That would be interesting, because I set up the kind of ensembling approach and ensembled about 4 models, but that got me only so far. But I haven't fine-tuned the thing, as you were saying. And I also tried, by the way, instead of using SVR, I tried to put gradient boosting, but that's too slow. So I have to see some way of maybe increasing its speed or something. I just wanted to try a different approach than SVR, but it was running, but it just kept running for more than an hour, and so I killed it and I had to figure out some ways. So if you could share how you do the fine-tune, and have you fine-tuned all of the models, every one of them?
Oh no, I've only done one.
Oh, okay.
Yeah, because I was trying some other stuff. Yes, like this notebook here is just the one that's the thing always gets away. Yeah, so this notebook is the one that's always in the public. So I haven't done much to it. So like when it comes, yeah, I think it's got like about 6 or 7 different notebooks. Yeah, so the first 2.
I didn't do the exact ones that he did, but I just followed the template and did it. But did you run as he's running, or did you actually embed and run the code, but just removed the variables like he has done?
Well, I've pretty much just gone with what he has, but I've only added in, 2, I think. Yeah, so like this notebook here, this is like one of the sort of the first notebooks or whatever. Yeah, like I think this is like the main sort of public notebook. It's just like, yeah, a Deberta V3 base sort of standard head on it. So like I'd taken this notebook, and this is the one that I trained. And so like I was able to get the hidden states from the final layer of that. But this is just the normal notebook. And then the only bit that I've really changed is somewhere in here. I've stuck the SVR notebook in. Can't remember where I put it, but it's in there somewhere.
I did that. Right.
And yeah, so like the bit that's probably giving me the boost at the minute is yeah, so like in Chris Diott's thing, yeah, so like in Chris Diott's notebook, he just takes the untrained models. So he has like these 5 here. So this one here, this Deberta base one, rather than using the untrained one, this is the one I'm using the fine tune from. So like the model I was just looking at back in the previous notebook, the public notebook, as I say, I was able to take its final hidden layers.
Yeah, that's what I was wondering. So did you train with the folds? Like, did you still, not this 25, but when you're training the Deberta base, you still have 4 or 5 folds?
Yeah, so I just took the public notebook for the Deberta base one as it is, kept with the 4 folds, just trained that, and then in here I've incorporated it in. Yes, so this thing here runs with 25 folds, but yeah, so here's the model from that other notebook, And yeah, so I've just trained it. I just took it and trained it again on the four folds. So you can see here. So like now that just gives me four models. And so like when I stick each model through with the test values or whatever, so that gives me the hidden state, and then I use that hidden state to stick it into the SVR list. Yeah, so.
But that's where I was wondering. So you load the four folds,
yes.
And then what do you do? How do you do you average the embeddings from each fold, or what do you do? How do you come? So you would have embeddings from each of the four folds, right?
Yeah. So like I just stick each fold, I add them into the text features array, and then like down the bottom, then yes, like then he uses the other the untrained ones, and he just adds them in. So yeah, like then down the bottom they just concatenate together. So
so you concatenate all of the folds, the four. So instead of having a single value like he does, you have now four values that you also concatenate.
That's right. Yeah.
I see.
Yeah. So here in his diagram, he would have deburred base and deburred large. He would have the hidden folds from this one untrained and this one untrained and this untrained, and he concatenates them together and then sticks them into SVR. But in addition, I've got like a box here which is four more, one from each fold. So that's where I'm getting like the little boost from.
Yeah.
So yeah.
And so do you have 5 for the deburrer base then, the 4 fold ones and his untrained one, or do you just use the 4 folds?
No, I've kept this one as well. Yeah, so I've got 5.
Okay, got it.
And yeah, so like I was planning to do the same with each of these others potentially. Yeah. I got a bit distracted though, because yeah, so like the deburrer base from the public notebook, it is just pretty basic or whatever. It is just like the deburrer base model and then like a single layer network on top. So like I tried sticking other heads on with like an SVR head and like a sort of a better neural network head on the top, and like then ensembling them, but it didn't give me any increase at all. Yeah, so then back in that other ensemble one, yeah, so I was all of these models here that are in this list, each one of these, yeah, so I've taken this one, and like it's the one I've fine-tuned and stuck into Christy Ott's SVR thing. So yeah, now I'm moving on to this one. So that's what's running at the minute. I've got this like training over here on Colab. But yeah, so like when this trains, hopefully if it gives me a reasonable score, but this is using like PyTorch Lightning, which I don't know that much about.
Right. Yeah, I don't either. And so you plan to use the 4 or whatever. I think this one has 5. So you would use the 5 embeddings along with the other embeddings then.
That's right. And this one here is actually, it's deburred large. So yeah, so it should give me a bit of variety. Yeah, like I don't know what all this is about. I don't know how to get rid of this rubbish. Yeah, it makes it a bit hard to see. Yeah, it makes it a bit hard to see the results because of the fact that it's just like swamped with this. But yeah, I don't know what that is. I've just noticed though, like this is training at the minute on Colab. I just noticed when I came to do the runtime that there's now separate GPU classes. Yeah, but
interesting.
I've also just noticed in the discussion for this competition that there's somebody talking about it, saying that Colab has changed its pricing thing. Yeah, this.
You have to pay more money to get premium.
Yeah, I don't know. Like it's like saying about you get 2 to 4 computing units per hour. Yeah, so I don't know. Like, have they changed it now? Whereas I'm being billed every hour or something as opposed to monthly. I haven't noticed any sort of change in the
No,
conditions?
yeah, I would be. I mean, I'd be shocked if they did that without informing any of us.
Well, maybe they did
Right?
inform us.
Because
Like, maybe they sent an email and I just ignored it. But,
no, I haven't seen. I usually um, um, do read whatever they send. And
yeah,
see, the other thing is, it's they if they do this, then they know that they'll lose. Sometime back, I had actually used Paperspace rather than Collab. It's somewhat more difficult from an infrastructure setup perspective, but it's somewhat easier because it uses traditional Jupyter notebook rather than Colab. So, Colab has all these weirdo, like you have to figure out where the data went, and, its notebook is not exactly Jupyter notebooks because you can't use the widgets, blah, blah, blah. And I use Paperspace, and Paperspace has stuck to the $8-9, and they've improved their user interface and all of that quite substantially. So, for example, the latest FastAI course, like his version after he moved to Australia that he taught, he was recommending Paperspace again rather than Colab. And so the reason for my detour through that is to say, if Colab guys switch it up and make it much more expensive, many people will just switch to Paperspace because that is still under $10.
yeah.
So I'll look into it, but thanks for calling my attention to it, because at least that way we can check.
Yeah, so as I say, I just saw that this premium thing, so I just chose premium. I don't know, does that mean I'm being charged premium prices because of the fact I've chosen it? But
yeah, no, but on the other hand, that's the thing, right? Like I'll check, and if I see something, I'll let you know in Slack, but I'd be surprised if they just Mayank says they've changed it. So let's look at what.
Yeah, I think they have changed some of the structuring there.
Some of the what, Mayank?
Structuring of the how you use the Colab. Now it comes with compute units. So in Colab Pro, you have 100 compute units per month. 100 compute units per month.
right.
And
they don't. What do they define compute units as?
Compute units depends on the GPU or the TPU that you select during your run. So V100s, V100s will have certain compute unit that is available to you, and you can look it up in the resource monitor. How many compute units, how much balance that you have currently.
And what do you do to invoke the resource monitor? Is that something, Steve, that you can see?
Is this view resources?
Yep, view resources.
Oh, so you have 141 left.
Right.
Yes.
See that 141, and in fact they say 100 compute units per month. So that means you have some leftover. Oh, you know what they're trying. So you have 41 leftover from the prior month. And then, by the way, I'm just staring at something which says that after 90 days it goes over. It expires. So you are better off using premium right now, because then you can eat into the 40 that you have not used from prior.
Right. Okay. Yeah, I just got a shock when I saw that thing. So yeah. Anyway.
And then, by the way, I'm just staring at the pricing thing at the link. What is interesting is They also have, you know, you and I are both on this pro $10 a month, $10 a month plan. They have a pay as you go plan, which is the same pricing as Colab Pro and Colab Pro Plus, because it's $10 for 100 compute units and $50 for 500. But the thing is, you pay only as much as you use on that one. So I don't know which one is better now, but anyway. And apparently that also, all of them says they now provide faster GPUs and TPUs.
Right.
So that's probably why you have the premium option now.
Yeah. I ran that thing to show what I've got. A Tesla P100. Don't know. Is that good? I don't know my GPUs.
Yeah, P100, Tesla P100. I have to go check what that. Don't know that it is.
Yeah, because I thought
this is for the. This is the premium one.
Well, I chose premium, yeah. So.
Okay, and you figure out what P100 is compared to what other, maybe a V100. I'm not very up on it, but it's not that hard to figure that out. Okay.
Yeah, yeah. And the only other thing I've done, I saw like this discussion this week to see why nobody can get beyond 0.43 in the leaderboard, and somebody suggested it's because of this. They're suggesting that all of the models, like because of the fact there's like substantially more instances of ones that have like 2 to 4. There's not very many that have labels of 1, 1.5, 4.5, and 5. So they're saying that, yeah, like sort of 4 out of 9 labels aren't sort of predicted. And that's where the 0.44 baseline sort of score comes from.
Oh, I see. So you're saying that the inherent data, but is biased in that range, if you will.
Yeah. So if you use techniques to generate more of these ones where there's not very many instances of those labels, then perhaps that would help things.
Yeah, that is where the thing I didn't get to. I wanted to. I was distracted, I guess, in stuff, but is this pseudo labeling, because we have so many more essays that aren't labeled, and we could. I haven't, you pointed to a notebook which talked about it. I think from the guy who also did this ensembling, the same guy.
Yes,
I think
right.
there was a discussion notebook. I haven't yet looked at that, but even without that, it should. Once you have like a model like yours, which is 0.42 or 0.43, or an ensemble model, we should be able to use that and run it on the 11,000 essays in FB1 and try to get a bunch of pseudo labels, and then use all of that data either directly as input to train the model, or kind of, I've seen a little more complicated version of doing that, where I think people, they use that at the first level and then use the more accurate data at the second level. I haven't yet, I have to go back and look into that some more, of how they use multiple levels. They use the largely potentially incorrect data to train the first crude model, and then train another model on the much more accurate data.
Yeah, I was wondering about like using pseudo label and like sort of just try and increase the amount of ones with those missing labels or whatever, as opposed to just generating more in the middle.
Yeah, that I wonder how you would do that, right? Like how would you, about after you generate all the pseudo labels, maybe you can pick from those because you have generated it for all the essays, and then maybe you're saying cull the essays which have more rank, more labels in that range, and then use just them.
That's what I was thinking. I don't know. I don't know. Does that help or not, or does it just because of the fact you'd be throwing away a lot of stuff? Then is that bad?
Yeah, that's what I was wondering, because you would, if the inherent data distribution is of that kind, meaning by that I mean, the essays in the 1 to 5 range are, or 1 to whatever range is in fact less in the actual data distribution, and the distribution is likely to be that way, then you're throwing away a lot of additional potentially good data. But anyway, we won't know until we try, I guess, as with many things. So,
Yeah.
but yeah, I did a bunch of stuff. I went from about 400 to 200, and then I got stuck or distracted. I didn't have the time to spend it. And I was also wondering how you had combined and, okay, so you just train it and then just use the embeddings.
That's right.
And concatenate.
Okay. Yeah, so just stick them in the SVR and then stick that SVR notebook into the other ensemble.
Right. Yeah. Now, so that training part of the thing, you stick it in the inference notebook itself, right?
Yeah, you've got to have the model in there. Well, you've got to have the model in there to be able to get the hidden states out of it.
Yeah. Okay. Yeah, that's what I thought. Yeah. Because the other thing I was thinking, and would like to hear your opinion on it. Isn't it the case that if you, for even the other models, let's say now, instead of the database, let's think about, whatever, we'll just call it the lightning model, right? The guy who's doing the lightning stuff. Yeah. Now, why can't we, I was thinking about this, wouldn't it be possible to just, and that guy has like 4 folds or 5 folds or whatever, let's say 5 folds, just for discussion purposes. So each fold has a model, right? So wouldn't it be possible, or shouldn't it be possible to just import that model and then access its hidden states, because the models still need the hidden states. They would, because the model still has those states embedded in it, right? Like when you describe the model and stuff, it would show you that. So why can't we just import that model and access its hidden states and then just extract them and stack them like you've done?
Oh, you can do that, yeah. The only reason I'm training it is because I wanted to try sticking whatever, SIFT and AWR onto it. I just wanted to try and see, could I improve its score before putting it in?
Okay, but technically there isn't a reason why I shouldn't be able to just get that model and access its hidden states to describe or whatever means, and then just use it, right?
Yeah, no, you can do that, yeah.
Okay.
Yeah, so as I say, I wanted to try a couple of other techniques to see if I could improve on the score of all of the public models first before using their hidden states, but you can do it without it.
Yeah, got it. Okay, I got it. Yeah, I went I have about 4 of the models, including the SVR as one of them. I haven't included the test one, and because the test one, just like Lightning, he uses his own library for training, and I haven't bothered to learn that and fiddle with it. So that's one. And there was one other one that he had commented out that I didn't. But on the other hand, I included, the SIFT, the Lex model, which he did not. but I'm sure I can find one or two more models, and maybe that'll get me from 200s to maybe in the hundreds. But then I'll, for sure, I was thinking what's boosted you up is the using this fine tuning on top of just taking the embeddings.
Yeah, I think so. Yeah.
Because just ensembling, at least for me, the 4 models, it improves it. I went from mid 400s to mid 200s, so a couple of hundreds twice, but it got me nowhere, not any closer. So I think, and also I was noticing that all these models, including even the SVR thing, because the SVR thing already is ensembling 4, in a manner of speaking. Is not ensembling, but is kind of concatenating the embeddings, right, of 4 models. And all of them are variants of Liberta. So that's the other thing I was thinking is, from my past experience fiddling with these, anything it uses Roberta or there was something else, one other kind of model, Electra. Those kind of things seem to work better with ensembling because then you don't have correlated models.
Yeah.
So that was the other thing I was thinking, is seeing whether I could train up a Roberta or an Electra model and see how it does. And even if that doesn't do as great, but then when you throw it into the ensemble, what happens? Oh, that's great that you're, so is it you're in gold or striking distance of gold or silver, or where are you at now?
Just outside gold it was, but as I say, I haven't improved this week and some other people have jumped up, so I'm dropping back a bit.
Go for your first gold then.
There's a long way to go yet, so
Then you would be like then you get into what, like a Kaggle expert or something, or what's the tag you get for that one?
I'm not sure. Sorry, I haven't looked, but I don't know.
But be cool. So Jack, Mayank, anyone else? Share what they were able to fiddle with or try?
Sorry, I've done literally nothing this past week, so I'm just listening here.
How about you, Mayank? Any chance?
Yeah, I tried the other notebook, the publicly available notebook, the Liberta family inference one, the FB3 Liberta family inference one.
That's the basic one that I think.
Yep.
That Steve was referring to.
Mm-hmm. Yeah. So there are a lot of folds here. So there are 10 CFGs, and each one has been folded 10 times.
Oh wow! Okay, so that's not the one I was looking at.
What score do you get you doing that then?
I got 0.43.
Oh,
Okay.
cool.
Yeah.
Oh yeah, it's in the notebook. It's in like the ensemble one, and it takes hours to run. Yeah, like it probably takes, I don't know, 70% of the ensemble time is that one notebook.
Yes.
Wow.
And yeah, like my ensemble's just coming in under the 9 hours at the minute, so and 7 hours is probably that notebook.
Oh wow! Mine finishes in like an hour or two because I only have 4 of them right now. So maybe I should include that one.
It is the Liberta family one. Yeah, like I think it's the one that gets the big boost up to 0.43, but it does take take forever to run. Yeah.
I see. I haven't included that one. I should go back and include that one. Okay. Yeah, like I said, I tried putting gradient boosting, and unlike, so the two things I realized when I did the gradient boosting instead of SVR, because I was thinking of what else besides SVR, and like you said, I think last time, like we discussed, I could potentially put just a neural network layer instead of SVR. The one thing about the SVR that he's using is he's based it on QML and Rapids, and therefore what it does is it does parallelize the computation for using Rapids, which is parallelize pandas, if you will, and running on GPU. And I was trying to see whether we could use gradient boosting, and that doesn't, gradient boosting for somewhat of reasons I understand, but if anybody else has a better explanation, I'm love to hear it. But I think gradient boosting, because of this sequential nature of what it does, meaning it does the computation and then finds the error and then tries to, in the next revision, tries to bridge the error, so to speak, right? Like narrow the error, and then it does it all over again until it converges. So the fact that that is sequential in nature, I think there isn't an implementation of gradient boosting in TWIML and Rapids and stuff, probably because it has to be sequentially done. And because of that, you can only do the traditional way, but there is a multi-output way of doing it, whereby the 6 outputs, because remember, you have to generate 6 values, and each of the values you'll be using gradient boosting on, which means per value you will predict and then try to narrow the error gap. But you can do each of the 6 values that you're predicting in parallel. So you can do 6-way parallel at a minimum, and that you can do with sklearn, multi-output, something. So I tried that, but still with the number of embeddings that you throw into, because this is again like a random forest kind of approach, but the number of, I just used the default parameters, which probably are not good enough to increase the parallelization and make it perform faster. So I haven't gone back and seen whether there is any faster way to use gradient boosting, or instead of SVR, which is an SVM kind of technique, whether throwing in a neural network itself rather than an SVR will give you a better combination of the embeddings than just using SVR head on top of the embeddings.
So wait, so are you saying that normally XGBoost can only output one number, whereas SVR can output more than one number?
The way that he has set it up in the short answer is no. In both output one number, but the additional parallelization that he does in the way the notebook works by using COML and stuff like that, he parallelizes, but he's still within the loop. If you see in the notebook, let me see whether I can bring it up, or I have no, I don't have the thing open.
Oh, do you mean like he just uses like 6 different SVRs, each taking in the same concatenated vector of embeddings?
That's correct. Yes, that's what I mean.
Okay. All right, so the
Yeah.
difference is XGBoost is just much slower than SVR. Is that
Yes.
word?
Yes.
Okay. I see.
But there is,
Thanks.
what I found is there is a way using a multi-output stuff in XGBoost and sklearn, where instead of, so let me see whether I can share my screen here to show you guys what I'm talking about. Otherwise, it's a lot of abstract rambling. So let me know whether you can see my screen.
Yep.
Okay. So if you see here, he does all the folds, blah, blah, blah. You know, sets up the notebook, gets all the embeddings, and then combines them. See here, this thing here that he's doing, he's generating for every, you know, like target column, right? So like syntax, vocab, blah, blah, blah. So he's generating the values, the entire, whatever, 3,000 rows, 3xxx rows of one column, right? And that's why this is in a loop. So he does that for one column, moves, does it for the second column, and he does it for 6 columns, right? Now, let's see. This is SVR, but the parallelization is because, you know, he's using the TWIML version, the Rapids version of SVR. Now, let me see whether I can get to my notebook that I was playing with. A second here. Okay, let me know when you can see my screen.
Yep.
Yeah.
Is this different from the last notebook?
Yes, it is, because I mean, I didn't edit all of it out, but I switched it to gradient boosting.
Oh, right. Sorry. Yeah. Didn't do that bit.
And so here, I mean, most of it is still the same. Where I changed it, you know, is when you see, you can use the multi-output regressor from sklearn multi-output, and then within it use gradient boosting regressor, right? So, and in this case, what you do is when you do the CLF, see here, the CLF is set up this way with a SVR, and then you do the fit, but you predict per column, and the multi-output, I believe, since I haven't seen the results because it ran for a long time, but it didn't error out. It seems you can fit and get the values for all 6 of them at the same time, because you're using multi-output. Because the multi-output regressor, what it does is it says, okay, instead of a single output, which is a single column, that is syntax or whatever, it actually does gradient boosting, but it says, oh, I have to do gradient boosting for 6 outputs.
So you've tried this, but you haven't, I mean, you don't know at the moment if it's improved things or not? Is that...
Well, I tried it and I didn't get it to run to give me scores successfully because it was just taking too long. And
okay.
I think, meaning, you know, even the first fold, I was not able to get an output even after an hour. And I thought that's way too long. And as you can see, I'm just using a default gradient boosting regressor with no parameters that I set up. And I said, okay, I think I need to go back. And again, gradient boosting regressor has a ton of parameters, right? Because it does this leaf thing and how you split and do you keep it coarse or not. And there is a whole bunch of stuff that you can do with it. And I was like, okay, I just wanted to try it first with default. Just like, he uses the SVR and just C=1 and, he doesn't fiddle around with the parameters. So I thought, let me also not fiddle around with the parameters, but that obviously doesn't work. So I need to see whether I can do something to the gradient boosting regressors parameters to make it coarser and to speed it up essentially and see whether I get results and then figure out whether the results are any better. At the moment, I have no results with this approach.
Do you know which one is slower XG boost inside a for loop or a multi-output regressor?
Don't know that either.
Okay.
But where by the way, the question, the reason I use this approach is interestingly, if you go back to let me see where the other notebook, here. So if you look at this guy's notebook, he took the idea of doing this ensemble, ensembling the embeddings from this notebook. Okay, and that notebook implements multi-output gradient boosting regressor, but not 25 folds. As you can see, and gets, because he doesn't do the 25 folds, he gets, partly because of the 25 folds, he gets, I think, a score of 0.45, whereas Chris Diote gets, is it 0.44, Steve?
Yeah, it is, yeah.
Yeah. So let me show you where. So this is, he just, a lot of this should look the same or identical. See, he's training a gradient boosting regressor. He has a whole bunch of stuff here, but eventually he uses a multi-output regressor. And he used the default thing too.
And this runs
uses
within
5
reasonable
folds
time?
rather than 25 folds. Sorry, you were saying, Jack?
Or so you were doing 25 folds, is that?
Yeah, I was doing 25 folds, yes.
Okay.
But here's the thing, right? I didn't even see, 25 folds, but I should see the result for the first fold at least, right? Very quickly, because the number of elements in a fold are much smaller, but I wasn't seeing that. It just kept running.
Okay, so you still feel there's something not quite right about your, okay.
The number of
And
elements
I
you're
still
trading
have
on
to
in the
find
fold
out.
are a bit bigger, aren't they?
I'm sorry?
If you've got 25 folds, your training set's slightly bigger, isn't it? Because the validation fold is only a 25th, as opposed to
you're right.
1/5.
Yes, it's
so it would take slightly longer, but probably not. Yeah. So.
Yeah, not an hour or so,
No.
because this thing, when you run the 25 folds, it runs like in a few minutes. So even if it were to be, like it runs in 10 minutes and it's, 5 times longer, it should be 50 minutes. So I gave it an hour and 10 minutes and it was still running at the end of it. And I was like, I need to go to sleep or something. So I killed it and said, I'll figure it out later. But, here's proof that you can use the multi-output with 5 folds. And that was the other thing I was thinking of, although to your point now, that doesn't seem like it would be the reason, is seeing whether 5-folds work. But here's an example where with the same data, the 5-folds seem to work, and it doesn't. You can see that his times are not crazy, right? It's like 30 minutes and stuff. So it doesn't seem like it's crazy. And he has used gradient boosting regression instead of SVR like Chris did. So the only two things Chris has done on top of it is 25-fold and using SVR and TWIML or rapids-based SVR on top of this notebook.
What about the number of input features into the multi-output regressor? Is it the same here as?
Yes, it's the same, because that he hasn't changed. Because if you see, he's using, here is the generate embeddings, and let me see. Yeah, see this one. Wait a minute. This is one. Let's see. Oh, so you've used only one embedding, I think. Whereas that guy combines 4 set of embedding. In fact, that point that you make is one that I was pondering, because the length of the inputs and how many of those you choose in gradient boosting, because gradient boosting is essentially subsetting trees and then trying to get them to work, right? And as the length of the concatenation increases, the number of subsets that you can potentially form explodes.
Okay.
Right. So
Yeah,
that was part of the reason that I was thinking that I might need to provide the gradient boosting regressor with some coarser choices of how to combine the embeddings. And rather than it may be trying to do the gradient boosting with selection of the embeddings which are too fine or too granular, because now you're combining, 4,864 versus in this case, because he's doing it with a single model, it's only, I don't know, maybe 1,024 or 768 or something in this range. Whereas now I'm doing it with 4 times the size. You see what I'm saying? The input vector that you give it when I'm doing gradient boosting is 4x what he's doing it with. And that causes an explosion to the gradient boosting regressor.
Okay.
Which is probably the reason that it's so slow. And I need to figure out a way to make that coarser, make its choice of those way it combines them to try and predict coarser is what I was thinking.
So I guess
to
maybe
speed it up.
Right. So SVR is probably less affected by the increase in the
input
number
dimension.
of input features. Yeah, okay.
Right. Yes. And in fact, he says that if I switch back, there is an interesting comment he made. Let me see. Where is that? Okay, here. See, there is one interesting comment I saw. Apparently, SVR, and that might have been the reason he used SVR. He says that SVR combines features or has the ability to combine features.
Oh, you mean like therefore reducing the number of?
Yeah, that's what I interpreted it as meaning. Did he have it in the original thing?
I think it was at the top there. Yeah.
Yeah.
Yeah, like you see,
Yeah.
he says there, somebody else did it for 6,000 columns.
Oh.
And more importantly, is this a built-in feature reduction? So it learns to use the most informative features from all the NLP transformers. Gradient boosting doesn't have anything of that kind, right?
To be honest, I don't know the details of these algorithms, but the fact
Yeah,
that
no,
he's put this
I mean,
at the top
yeah,
probably
but,
explains why he uses SVR.
right, exactly. But this line I thought was interesting.
Yeah,
And
his
that's
SVR
kind of
is,
what I'm fighting.
his SVR training is really, really quick as well. Yeah, like in the discussion bits, he has a comment about it, and he's changed the things now. Yeah, so it takes 30 minutes or something for these models to get the hidden states, and then it takes 1 minute just to train the SVR, so it's nearly instant.
Yeah, it's very, very quick.
He says like 6,000 columns of features here. Is there like upper limits to like the number of columns that SVR can take?
I thought he'd said about in some other competition, maybe he doesn't say it in here, but in some other competition, somebody'd sort of had something like 30,000 columns and used SVR on it successfully. So
oh yeah, I think I remember. Yeah, it was something ridiculous.
So I think you can take quite a few.
Yeah. That's pretty cool. No wonder it's always used for really large ensembles.
Yeah, the only problem I had with it was I tried to take this notebook and I run it on Colab during the week. And Colab doesn't have Rapids on it. And to put Rapids onto Colab, it's like a real pain. It takes about half an hour or something, so I just gave up. So
isn't it just pip install?
No, it's not. You got to play about and take things off and put other things on and stuff. And I couldn't even get it to work. But it's yeah, you'd have thought it would have been, but it's not. Whereas it's like
yeah, that's also because like it
Kaggle.
could have Rapids as this underlying CUML and CUDA dependencies which don't align then with potentially, you know, PyTorch or other things that you're using and the versions of CUDAs. And by the time you figure all those conflicts out, you're like lost.
Yeah, like it wasn't worth my while. It was going to take so long to put it on. So.
Maybe you can contact customer service and have them like so that they can make it available by default, like in Kaggle.
Perhaps, but I think other people have been asking, and I don't think it's ever happened. So
it's probably as much issue of Rapids is an NVIDIA thing, and underlying Rapids are CUDA and CUML and stuff, which are also NVIDIA things. And it might very well be a question of getting those to work on, but I don't know why it should be that hard to then work with. It wouldn't be Colab. It would probably be, you know, playing nice with PyTorch and stuff, I imagine, because Colab per se shouldn't have too much of a dependencies on those that I can think of, but who knows?
Yeah, but like if you're just gonna lose, sorry, I mean, if you're gonna lose computing units because, I mean, just waiting to have Rapids installed, I mean, yeah, it might not be worth it.
Yeah. But good to know that there is now all these compute units, whatever the hell that means. But it seems like it's still fairly liberal. I have to check how many units I have left as well, because if I'm going to lose it, I might as well run a bunch of stuff on Colab.
I was looking at that link.
Sorry, Jack.
Mayan shared that link for Colab sign up. So does that mean, because I haven't used it for a while, does that mean there is no Colab that is absolutely free now?
That's a good question. Whether there is a totally free version of Colab that you can use versus not. I don't know. Steve, you know?
I'm not sure. Sorry, like as I say, I hadn't realized that Colab itself had changed to this compute units thing until I saw that Kaggle discussion.
Yeah, even I hadn't. So thanks for bringing that up, because but I wouldn't have known either. They did, strangely enough, they never told their users. They still kept, I mean, I get the billing notice and each month I pay attention to it just to make sure they don't charge me more than what they should, and it's just the same $9.99. But
so according to that, it's like you, unless you're going with pay as you go, like you'll just like run out of computing units and you won't be able to do anything more till the end of the month, right?
It sounds like
yeah,
it, yeah.
and
So
yeah,
you're always
except
paying
I
the same
think,
thing anyway.
yes, correct. But knowing Google or any of these, they'd probably at that point come back and say, would you like to switch, or would you like to go to, Pro Plus, or would you like to pay as you go?
Right.
Rather than
Okay.
just drop you dead, they'd probably say, give us money and we'll let you run.
Or maybe you haven't been using enough.
Exactly. No, definitely it shows on Steve's usage, right? And mine is even less, so probably will show, which is why I'm saying I'll go check on it now. Is he has 149, and which means that somehow he has 49 units more than the 100 allocated per month, which means he has 49 carried over, so to speak.
How many hours is that roughly?
Yeah, that's the translation. I have no clue, right? Because they just say compute units and it's unclear what that translates to.
Yeah, so I
I'm
think
sure
it depends
it's
on
there in
what
some
you.
documentation.
Yeah, so I think if you choose the whatever they're called, the more advanced GPUs, I presume that they take up more compute units to run. So
Yeah, just
so
wondering
that's why
how
you probably pull it down faster if you choose premium.
yeah.
Yeah, I just
but the
wonder
more
how it
interesting
compares
question
with
is,
Kaggle's 30.
if you're already running it, Steve, the more interesting question is, without setting premium, if you're running a very demanding job, whether it actually switches to premium and switches back when it doesn't need it. And that's the more interesting thing.
Yeah, like I was wondering as well, like if the premium one, say, takes 3 hours to train my model and the non-premium one takes 10 hours to do it, how many compute units do each of those use?
Yeah, exactly. That's why I am curious on the definition of compute units and how it all works. That's one area where, OS is really, really excellent, because they actually, I haven't experienced it myself, but I have read a blog where the guy shared these details. I don't know whether they do it now. It's been a couple of years since I saw the blog post. But in a blog post, the guy had said that he was running a fairly complex thing, and OS actually monitors the run, and it came back and told him, or no, in fact, it was the following thing that happened, that he ran a job to completion, and then it was a fairly, long job, like multiple hours a day, half a day or something. And then it seems he saw an OS refund in his account a few days later, and it seems they said in the message that, oh, we noticed that your setup was not optimum for running that. And if you'd run it in this setup, which is the optimum setup, you would have only taken 7 hours versus 12 hours. So we are going to only charge you 7 hours for that. And in the future, use this configuration settings. I thought that was really awesome. I don't know whether they
really
still do it. Sorry?
Yeah, it sounds good of them.
Yeah, because they are monitoring, in fact, it goes to what Steve just said, right? Like, so if Google is monitoring your run and it figures that you would end up using less compute if you ran with premium, then I would rather that they just switch to premium and ran it and made the best use of their resources and best use of my money. But don't know whether they do that. At one time or
do
that. Yeah, but that is true customer service, right? I mean, that's why I was impressed by what Oz did. But at one time, I don't know whether they still do it. Okay. Any other questions, Yuri or Terence or anyone else?
I have a question, but it's not on this competition, so maybe like I'll go at the end.
Go for it.
Okay. For time series prediction for the cryptocurrency competition, you did quite a few of reviews at the end of methods, right? Was that recorded? So the reason for my question is, so normally I didn't need to do time series predictions, so especially like this kind of regressive prediction, but now I do. So I want to look what methods kind of worked at the end.
Yeah, I don't recall, Yuri, whether we did like we used to in the past, whether we went through at the end reviewing techniques. I'd have to ask Jack and see whether they remember. I think we did it more on the fly because I think I was trying to, and then Jack was trying to use a deep learning based model for that someone had published for time series, and at least to my recollection, I did not get it working. Jack was trying to get it working for a lot longer than I did. I don't remember whether he got it working, but the short answer, unfortunately, is I don't think we spent a lot of time after the competition ended discussing the various techniques. Do you, Jack or Steve, remember it any differently than I do?
Right, I didn't get that package called PyTorch forecasting to work. I think like Steve did best like in the time series competitions, right? You did really well in the Ubiquant, and yes, so
I did well in the Ubiquant one, but it was more like just a tabular competition. It wasn't really time series, although they billed it as that. It wasn't really. And then we did another time series one, but I was just using it basically to sort of like learn about time series, and I was just using sort of basic the sort of mainstream time series techniques, and I was using like random forests and things on it. But I know like now, yeah, like there's a lot of interest, isn't there, in using transformers for time series, but
yeah, so my recollection, Yuri, of that is we didn't have a discussion at the end like we did in the past about the techniques. But what I can tell you is, you know, and in fact, you had even pointed to, there is this ongoing yearly competition. I forget what it's called, but the last winners, and I should be careful when I say last because it might be the 2 years back winners were the first time deep learning, and as Steve said, one of the models was, I think, a transformer-based model as well. And if you go to that publication, and I'll see whether I can, in fact, I think you had even pointed to one of them. There's this annual time series competition that.
M5?
Yeah, and there might be an M6 now. And if you look at M5 or M6 related data, that is what will point you to the best models. There were 2 of them at the time when we were doing the crypto competition, which is the competition that was actually a time series and that preceded the Ubiquant competition. And the crypto competition was very frustrating because just getting the data into the format was took most of the time. So we were very frustrated with that because we didn't get to use many of the techniques because we were just fiddling with the data so much that we decided to do one more. And Ubiquant, it turns out, as Steve rightly pointed out, that it wasn't so much a time series as just tabular data. But the most... Go ahead.
I find the difference between, a time series competition and a tabular competition. I mean, it's not so clear cut, right? I mean, is it? I mean, is there a very particular definition of a time series forecasting competition?
No, but I think I understand what Steve means, because I think in Ubiquant, now I'll have to go back and look at the data and to clearly explain, the nuances of the differences, but I do think there was a difference between Ubiquant and the crypto competition.
Yeah, like in the Ubiquant competition, all of the data had been normalized and they didn't tell you what any of the columns were. They just said, here's the columns, features 0 to 250 or whatever. Whereas in the cryptocurrency one, they told you the time period, they told you what everything was, and it was all about 25-minute sliding windows and stuff. And their score was all based over those windows. And as you say, it was you had to spend all your time trying to get those windows in order and go 25 time steps, whereas the time steps weren't clear in the Ubiquant one. They didn't actually tell you what the time periods were. They just said, here's a time indicator, but the difference between each period could be different and stuff.
Right. So basically the difference is you need to have explicit timestamps to qualify as a time series competition.
I think so. Yeah. I think if you want to use all of the proper sort of time series techniques, you need to sort of know what the period between rows in your data is.
Okay. All right. So otherwise, it's just like in the case of Ubiquant, it's just sequential.
I'm not even sure if it was sequential or whatever. There was just some time indicator, and you didn't even know were they coming after each other and stuff. So I don't think anybody really used proper time series techniques on it.
Yeah, that's why I called it tabular, right? Because it just entered in tables with no awareness of or indication of the gap between when the readings are taken, for example. That's just a bunch of readings.
Yeah.
In a table.
One good way to get reviews is to read the past winning solutions. You can just look up time series competitions that are most similar to the problem at hand, and then maybe try to read up the.
So M5 or M6, if you see documentation you read, that would probably be the best. The second suggestion I would offer is, the link to this Sanyam Bhutani thing that Steve had posted and I had posted too, of, he covers past competitions, and he hasn't done it for too long, but you might want to scan it to see whether there are any time series competitions that he covers, although fair warning that he covers them cursorily, but at least that can be a pointer for you to go look into those solutions in more detail in Kaggle. I don't know whether he has in the past covered any time series competition, but that is something else I would check out.
Cool, thanks. Yeah, I forgot about M5, M6 completely. And, yeah, that's a good idea because so yeah, in general, I haven't done this kind of autoregressive time series, and we need to quickly do something, and yeah, it's trying to.
Yeah, and the M5, M6 are the best summaries because they, in my opinion, after having looked at them, they really kind of point you to whatever is needed, a whole slew of techniques. So it's not like the latest and greatest deep learning one and that's what is favored. They evaluate techniques from a variety of perspectives, simplicity, efficiency, blah, 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 and all that. So that'll be an excellent starting point for you if you just need something to work and not the most complicated thing to work.
Cool, thank you.
And which reminds me, the other thing I was thinking of, Steve, is if you're on 0.43 and stuff, and I haven't gotten there yet, so obviously job one is to try and get there. But you know, if there is more time, the other thing I was thinking of is to, in this competition, maybe once you have that model, to then possibly follow the NLP with Transformer book. I think it's chapter 8, to try and build a distilled model, a distillbert version of the model, and see whether distillation helps you get to a much more efficient single model.
All right, I haven't got that far in the book yet. I think I'm only on chapter 4, so I'll need to read ahead.
But I was just thinking, hey, that would be a cool experiment because they also care about efficiency. And here is an example of, hey, you have 6 or 7 ensembles, and all of them, thankfully, are BERT or DBERTA based. So that distillbert should, well, distillbert is BERT based. So I don't know whether for DBERTA, Mike, you know, whether for DBERTA models, is there any kind of distillation preferred model that is used for distillation?
No. No idea.
But it should be easy enough to find if you scan on the web whether the, you know, what people have used to distill a DBERTA model. But that would be an interesting exercise. Just I was thinking, even if the competition ends, I might set that up as a to-do for myself so I can use a real-life example besides the one they have in the book to try and implement the techniques and see what troubles I run into. Okay, good deal. Thanks everybody for joining. Unless there's any other questions, we'll do it again next week. And hopefully Steve will be in the gold medal zone by then.
I'll try. So hope to see you there.
I have to keep trying to kind of come up your tailpipe too.
Okay, cheers. See you next week.
Well, good. See you all next week. Thanks. Bye.
Bye.
See you.
Thanks. Bye. Take care.